Hello everyone, my name is Angela Zon, and today I'm going to present to you on unlocking the potential of LLM-based recommender system, a work that I've done with some of my colleagues, and later on, at the end of the presentation, I'll show you some of the details to the team members. So, we are talking about using getting the LLM-based recommender system, or trying to find the potential in this case. I want us to take our mind back and think of, for instance, Professor Mars, who is in charge of our team, wants to purchase a product for us today, or want to decide which of the operation system are we going to use. Then it will need to make a decision, and also it will need to base its decision on various recommendations and even our needs or our personal needs in this system. There comes a question: which of these existing operating system is he going to settle for? Definitely, it will go to if there are existing reviews about this, the operating systems, it will then take a look into each of them, and probably it will choose one of the operating system which has been given the most positive reviews. But then doing this manually will take like forever, or he might not even get the right choice of the product. So that is why we want to dig deeper into these recommender systems, which are specifically for the softwares for helping product managers or managers of any institution to just make decisions on which of the softwares, based on their requirement, should they purchase in that case. Recommender systems have been used before, and there exist several traditional recommender systems. For instance, we have the collaborative filtering, we have the content-based recommender systems, which exist, but all these recommender systems that already exist, they are suffering from what we call the cold start. This is the case where if a new product is introduced to the market, then the recommendation for this new product is not easy to be done at that instance. Or if a customer has a new need, the system cannot be able to recommend any other product in that case. This is because most of the times we don't have the ratings, we don't have the reviews used in building these models. And what is mostly used to build up these models is the ratings. And as we know, in the normal society, because all of us, I assume we have done some online purchase at some point, and we were required to give the review and the rating. For instance, if now Professor Mars tries to is trying to check for the product online, and is able to buy, let's say, the Windows software, operating system software, and is trying to give back the recommendation on what the review on how this Windows is working. He might say it's easy to use, but difficult to maintain. In that statement, he has given two sides of the review, the negative and the positive ones. And now, what could be his ratings for that instance? He might give 1, he might give 5, but then these ratings will not be relevant or will not be in line with the review that he has given. And therefore, if we are using the traditional systems, if somebody else is using the traditional recommender systems to try find a product, and more managers, just like our Professor Mans, has given such reviews and they have given ratings of 1, definitely this product will not be recommended to the next person because of the rating that have been given. But based on what the reviews are, maybe it could have been the best recommendation for that instance. Under this, we are not the first ones to use the LLM-based recommender system or to come up with the idea of LLM-based recommender system. We have some people in the past who have done or who have worked in this work on LLM-based recommender system. And what has been found from the existing work is that LLM provide an opportunity to cover user preference and thoughts However, the use of reviews into this recommender system is still an open challenge. That is why we are coming in to introduce a new way to now use the reviews and extract as much information from the reviews as possible, and later use the scores that we generate from the reviews to be able to make our recommendation during the ranking phase. We want to test whether we can integrate retrained LLMs to enhance the simple rank-based recommendation system in this case. And we are going to show in the pipeline in details on how we are achieving this. From what we already know, retrained LLMs of many choices may affect the recommendation system's performance. So we tested different LLMs before we could settle for the best one, which we used for word embeddings generation in our case, and even for our ranking score computing. So on the case of data, there's been a problem in existence of data sets which are for softwares. This is because maybe of what is happening in the market in terms of the competition in that industry. But we were lucky enough to get data from Amazon. All of us, I think at some point we have ordered a product from Amazon. So Amazon has a lot of product reviews data sets, but in our case, we were only interested in software data sets to use in our research. So this is publicly available, and so it has about 17,000 software reviews. From the Amazon datasets, we got the reviews, we got the products, we got the product description, ratings, and the prices. But then there was now a case where we were needed to make our model or our pipeline as convenient as possible, and we wanted it to even take in the user or the person who wants to order for the product or who wants the recommendation as much flexibility as possible. So we wanted to also incorporate the prices, like the licensing fee, the implementation fee, and the maintenance fee. So we generated all these or simulated all these from the price that we are given. And the new ratings, we simulated them from the reviews that we were given in the data set. So I talked about a case where most times traditional models suffer from cold start because they have, in most cases, only the ratings, which has just a limited information in this case. And this is evident from what we can see in the Amazon data. From Amazon data, we wanted to see if what we are seeing or what we believe is happening in the industry is what is really like existing in analysis. So we got this plot of the count of each of the ratings, number of reviews, and reviews are both negative and positive. So we have reviews, negative reviews are in blue. So what we can see from this is that products that were rated as 1, almost more than half of them had positive reviews. But because of that instance, I said, for instance, if you give a two-sided review, in most cases, we'll tend to give to underrate that product is being evident here. And you can even see the, at the rating of 5, still, there were products which had very negative reviews, but still, because of the feeling the individual who gave the rating at that time maybe had, they had a rating of 5. So if we want to base our recommendation in these ratings, it's most probably to a greater extent we are going to mislead the person who wants us to recommend products to them through our model. So in our methodology, we had to cut it all to work it into 2 sections. That is, we have the word embedding generation section, and then we have the recommendation generation part of it. So the first part on word embedding generation. So we have the request, request, this is the description of the product that you want. I talked about Professor Mas wanting to buy an operating system for the people who are working the team. So definitely he would just type in the description of what he wants, maybe an easy to use interface operating system. And he will just give more and more information about that. Then he will say, our budget range for the price is, initial price is this. Then our range for the implementation cost is this. And what happens in that, we will just have the request coming in. We'll do filtering based on, the prices to make sure that the products we are going to recommend to him are ranging within the budget that he had. Later on, what happens is from our request, we had the description and the prices. Prices, we have used them to get the filtering, to filter our data. What about the descriptions? The descriptions, we will now generate the embeddings. We'll compute the word embeddings of the description that has been given as a request. And also we'll generate word embeddings for the description of the software that are existing. After that, we will now go ahead and pass these embeddings to similarity check. We'll compute the similarity between the request that was given and between what was given as the request and what we have in our database or what exists in terms of the software. And then it will pick those that are most similar to the requests that were made. And what happened after that, we are going to now go to ranking these products that are similar. We need to rank them according to the rank score so that we know which is the most recommended and which is the least recommended. To do this, we use the ranking score, which we calculated from our reviews, product reviews. And how we got the ranks were to first generate the positive score using the zero-shot method, LLM method. And we generated the positive score and the negative score. So what we are taking is, we are taking the total positive score from all the reviews of each product. We minus the total negative score from all the reviews of this same product. Then we multiply by the total number of reviews this product had for us to get the ranking score of that product. And after that, we'll have our products ranked from the most preferred, that is the one which has the high rank, to the least. And then we'll now give a recommendation to our user, who is in our case, Professor Mas. So from what was our result when we tried? So we cannot give a model out there before we try it. So we were to implement it. In our case, we typed in the request HR program for managing employee records on Windows platform. And we first wanted to assume we have not calculated our ranking score, which now solves the popularity gap that was there from the LLM research work that had been done initially. And our base model was us taking the general query, we compute the embeddings with the MPNet, and then we try to rank it based on the average rating, because this is what is mostly used. And from the average rating, what we see is that we add 3 first products, each of them having an average rating of 5. But the question we have is, of these three products, which of them has the most positive reviews, which we cannot answer from the information that we have used in this case. But if we move to our pipeline, where we now give the query HR program for managing employee records on Windows platform, the same query that we used in our baseline model, what happens is still the word embeddings are being computed by MPNet. And now we see that we have the first 3 which initially had the same rating. Now we have different ranking score. So you see, with us now using the reviews, we have been able to differentiate which of the products that were initially recommended based on the ratings is really what has buying in that instance, or is really what our model to recommend to Professor Mars if he was the one in this case wanting to get the product. And therefore we can see with what we are trying to do, it's more trying to cover the popularity of the product and also trying to extract the information which is contained in reviews, which has been ignored in most of these studies and which we feel is more relevant when it comes to recommendations. So what was the whole idea of the presentation? First, we started by defining the problem, where a case where we have noticed there is bias in reviews and ratings, which are supposed in the real sense to be the same. That was the diagram that we had, and we could see evidently that ratings and reviews given by customers are not as they are supposed to be. Because in the normal case, we could expect a highly rated product to have the most positive reviews. And a product that has a very low rating is supposed to have like negative reviews. But this is not what was showed if we use the normal ratings. We went ahead to take you through the pipeline of the work that we are doing or we are trying to participate in, which is still open in terms of LLM research for recommendation system. And finally, we had the results which we had from the baseline and our model to compare and show you that indeed we are trying to achieve something from our model, or our model tried to bring some importance or some substantial result into the field of recommendation system on LLMs. Up to that, I say thank you for your attention. And in case you want to reach us out, this is our team. It's Professor Mars was the supervisor of all of us in this team, and you can always find him on the internet. And all of us, we are in LinkedIn. We can always also reach out to us in case of any questions. You can also reach out to me through the email that I've provided on the screen. Thank you.